Welcome to Chemistry Academy, Fajanda High School and Junior College, Vahur. Now student, our next part of halogen derivative is physical properties. Physical property of halogen derivatives. Now in previous lecture, previous videos, we have discussed common system, IUPAC nomenclature, classification and method of preparation of both alkyl halide as well as aryl halides. Now today's lecture we will try to cover the physical properties. In case of physical properties, we have to discuss three parts. First one is here nature of intermolecular forces. Second, boiling point. Third, the solubility of alkyl halides. Now first part I am going to start nature of intermolecular forces. Now I have written the common example of alkyl halide. Suppose the hydrogen atoms or alkyl groups are attached here and X may be Cl, Br or I. Now actually we have to discuss the nature of CX bond and the nature of alkyl halide. Now in case of alkyl halide, halogen atom, it is highly electronegative. Halogen atom, it is highly electronegative. Now in case of periodic table, the left to right electronegativity character goes on increases, and halogen, it belongs to group 17, extremely right hand side of the periodic table, so it is highly electronegative. Now halogen atom, it is highly electronegative as compared to the carbon. So this halogen atom acquired the shared pair of electron. हाइड्रोजन एटम क्या करेगा, अपने तरफ इलेक्ट्रॉन को खींचेगा, एंड एज अ रिजल्ट दिस हाइड्रोजन एटम एक्वायर्ड अ पार्शियल नेगेटिव चार्ज, and the carbon to which halogen atom is attached, it acquired a partial positive charge. Carbon, it is less electronegative, so it acquired a partial positive charge, and halogen, it acquired a partial negative charge, and in this way a polarity will develop. Polar means one end is negative and another end is positive, like your south and north, north and south. Okay, so this one is your polarity, and due to this your alkyl halide, it is moderately polar covalent bond. Alkyl halide, it is moderately polar covalent bond, and the nature of CX bond is polar bond. So this is my first point, nature of intermolecular forces. So in case of nature of intermolecular forces, what you will write? In case of alkyl halide, halogen atom, it is highly electronegative as compared to the carbon. As a result of electronegativity, this halogen atom will acquire a shared pair of electron. As a result, it acquired a partial negative charge, and carbon will acquire a partial positive charge, and in this way this bond become polar covalent bond, and alkyl halide become a moderately polar covalent molecule. Okay, now this is the nature of intermolecular forces. Now amongst alkyl halides, suppose I have written here alkyl fluoride, next one alkyl chloride, next one alkyl bromide, next one alkyl iodide. Now these four alkyl halides are given to us. Okay, now when we will see the bond length, the distance between carbon and halogen, now this distance is called as the bond length. So when we will move from alkyl fluoride to alkyl iodide, this bond length goes on increasing. Because top to bottom means from fluorine to iodine, atomic size goes on increases, and as the atomic size increase, the bond length will increase. तो किसमें bond length ज्यादा रहेगा? alkyl iodide में as compared to alkyl fluoride, alkyl chloride and alkyl bromide. So when we will move from top to bottom, fluorine to iodine, its atomic size increases. As a result, the bond length will increase, but the bond strength will decrease. from alkyl fluoride to alkyl iodide, bond strength will decrease. Bond length will increase, but bond strength will decrease. And this is my first point, nature of intermolecular forces. So here alkyl halide is moderately polar covalent bond. The nature of CX bond is polar bond because halogen atom is highly electronegative, which acquired a partial negative charge, and carbon bearing halogen acquired a partial positive charge. And from alkyl fluoride to alkyl iodide, the bond length will increase, but the bond strength will decrease. And this is my first point, nature of intermolecular forces amongst alkyl halides. Now our next part of physical properties, second part is boiling points. Now actually the boiling points of alkyl halides depend upon the polarity, or we can say the boiling point of alkyl halide is measured or determined by the polarity. Now the boiling point of alkyl halide, it is greater than the boiling point of alkane. Boiling point of alkyl halide, it is greater or higher than the alkane. And why the boiling point of alkyl halide is higher as compared to alkane? So the reason, because alkyl halide, it is highly polar and high molecular mass. Alkyl halide, it is highly polar as compared to alkane, and alkanes are non-polar, and that's why the boiling points of alkyl halides are higher than those of the alkanes. Now within alkyl halides, my second point, within alkyl halides. Now within alkyl halide means, suppose here four different alkyl halides are given to you. One is your alkyl iodide, second one is your alkyl bromide, third one is given your alkyl chloride, and last one is given your alkyl fluoride. Now we are saying the boiling point depends upon the polarity. Okay, and alkyl halides are polar, and that's why the boiling point of alkyl halides higher than the alkane. But within alkyl halides, amongst alkyl halides, which has a higher boiling point, so the boiling point also depends upon the size of halogen atom as well as its mass. It depends upon the size of halogen atom as well as its mass. Now when we will move from fluorine to iodine, its mass goes on increasing. The mass, molecular mass of fluorine is 19, chlorine 35.5, bromine 79.9, iodine 126.9. Means when we will move from fluorine to iodine, its boiling point goes on increasing, and as the boiling point, its mass goes on increasing, and as the mass increases, boiling point goes on increasing. Means the boiling point of alkyl fluoride is less than alkyl chloride, alkyl chloride is less than alkyl bromide, and alkyl iodide is greater than alkyl bromide. So this is the boiling point sequence. So which has a higher boiling point? So the boiling point of alkyl iodide is greater than alkyl bromide, and which is greater than alkyl chloride, and which has a less boiling point, that is your alkyl fluoride. So as the mass goes on increases, its boiling point goes on increasing. Now in case of same alkyl halide, suppose I have written here CH3, CH2Cl, and propyl chloride. Now second one, CH3CH2Cl, ethyl chloride, last one methyl chloride. Now in this case my halogen atom is same, that is Cl. In all cases my halogen atom is same, that is Cl. So which one has a higher boiling point? किसका boiling point ज्यादा रहेगा? Either N-propyl, ethyl or methyl. So third point, boiling point rises और increases as the number of carbon atom increase. जितने कार्बन एटम ज्यादा रहेंगे उसका बॉइलिंग पॉइंट क्या होगा, ज्यादा होगा, बिकॉज इट्स मॉलिक्यूलर मास इंक्रीजेस. ओके, एंड एज अ रिजल्ट द बॉइलिंग पॉइंट ऑफ एन प्रोपिल क्लोराइड विल बी हायर देन एथिल क्लोराइड and ethyl chloride will be higher than methyl chloride. So first point, boiling point of alkyl halide is higher than alkane because it is a polar, moderately polar covalent molecule. Second, within alkyl halides the boiling point goes on increasing as the size increase and the molecular mass increase. So from fluorine to iodine, when we will move from top to bottom, atomic size will increase. पीरियोडिक टेबल में हमने स्टडी किया है, एंड इट्स एटॉमिक मास आल्सो इंक्रीजेस. तो एज द मास इंक्रीज बॉइलिंग पॉइंट विल इंक्रीज. सो अल्किल आयोडाइड विल बी ग्रेटर देन अल्किल ब्रोमाइड, which is greater than alkyl chloride, which is greater than alkyl fluoride. Now in case of same alkyl halides like n-propyl chloride, ethyl chloride, methyl chloride, as the number of carbon atom increases, its boiling point goes on increase. Here 3 carbons, here 2 carbons, and here 1 carbon. My last point related to boiling point in case of isomeric alkyl halide. In case of isomeric alkyl halide. Now isomeric alkyl halide means primary alkyl halide, secondary alkyl halide, and tertiary alkyl halide. So in case of isomeric alkyl halide, our order of boiling point is primary alkyl halide is greater than secondary alkyl halide, and secondary alkyl halide is greater than tertiary alkyl halide, because as the branch increase, boiling point goes on decreasing. As the branch increase, boiling point goes on decreasing. तो किसका boiling point ज्यादा रहेगा, primary alkyl halide, उसके बाद secondary alkyl halide, and then tertiary alkyl halide. So this is second physical property, boiling point of alkyl halides. Okay, polar covalent bond. Within alkyl halide, size and mass is important. If same alkyl halide is given, then number of carbon atoms. If isomeric alkyl halide means primary, secondary, tertiary, branching. So as the branch is given, its boiling point goes on decreasing. So primary, secondary, and tertiary, you can take the different example of here. Now my last point related to the physical property, that is solubility of alkyl halides. Now in case of physical property, the last physical property is given, it's solubility. Now actually solubility also depends upon the polarity. Alkyl halides are moderately polar covalent bond, and as a result alkyl halides are insoluble in water. Alkyl halides are insoluble in water. Why, that we will discuss. Okay, so what is the solubility of alkyl halides? Due to the moderate covalent compound molecule, alkyl halides are insoluble in water, but alkyl halides are soluble in non-polar organic solvent. It is soluble in non-polar organic solvent. And why it is insoluble in water but it is soluble in non-polar organic solvent? Because alkyl halides are inability to form hydrogen bonding with water. Alkyl halides have a inability, मतलब it is not capable, वो bond नहीं बनाता, hydrogen bond with a water molecule, and that's why alkyl halides are insoluble in water but soluble in non-polar organic solvent. So dear student, this is our physical property of halogen derivative. First point, nature of intermolecular forces. Second important point, boiling point of alkyl halide, and third point, that is solubility of alkyl halide. So what is the nature of intermolecular forces? So the CX bond is polar because halogen is highly electronegative. As a result, the alkyl halide is moderately covalent compound. Okay, now second point, boiling point. It depends upon the polarity. Boiling points depends upon the size and mass. Boiling point depends upon the number of carbon atoms and branching. As the branching increases, boiling point decrease. As the number of carbon atom increase, boiling point will increase. As mass and size increase, boiling point will increase. Now come to the solubility. Alkyl halides are insoluble in water because alkyl halides are moderately polar covalent in nature, and they are inability to form a hydrogen bond with water molecule, and that's why alkyl halides are insoluble in water, but alkyl halides are soluble in non-polar organic solvent. So this is all about the physical properties of alkyl halides. Now before going to end today's lecture, I am giving one question. Find out the boiling point order in a given molecule. Boiling point order in a given molecules or in a given compounds. Now here first one is given 1 bromo butane. Second one is given 2 bromo butane. 2 bromo butane, and last one is given 2 bromo 2 methyl propane. 2 bromo 2 methyl propane. Now first one is given 1 bromo butane, second one is given 2 bromo butane, and third one is given 2 bromo 2 methyl propane. Now 1 bromo butane is CH3, CH2, 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 Br. Now this is 1 bromo butane. Now 2 bromo butane is CH3, CH, Br, CH2, CH3. Now this one is here 2 bromo butane, and last one 2 methyl. Okay. Now this one is your CH3, then Br and CH3, 2 bromo 2 methyl propane. Now when you will see in all cases, in all examples, when we will see the molecular formula is same, that is C4H9Br. What is the molecular formula? C4H9Br. Okay, the molecular formula is same, but the structural formula is different. Now here 1 bromo means it is primary alkyl halide, 2 bromo means it is secondary alkyl halide, and this one is your tertiary alkyl halides. Now my question, boiling point order in given molecule. Now student, tell me which has a higher boiling point and which has a less boiling point and why. Now this is the example of isomeric alkyl halides, and as the branching increases, its boiling point goes on decreasing. तो किसका boiling point ज्यादा रहेगा? 1 bromo butane because it is primary alkyl halide. Then 2 bromo butane, it is secondary alkyl halide, and least boiling point किसका रहेगा? 2 bromo 2 methyl propane because it is a tertiary alkyl halides. Such type of questions are expected. So try to remember, this is the example of isomeric alkyl halides. Okay, so this is all about the physical properties. Now in next video we will try to cover optical activity. Okay, what is stereoisomerism, what is optical isomerism, what is optical activity, chiral carbon, chiral molecule, all that part we'll try to cover in my next video. Thank you.